Okay, I'll get started. So after that great introduction to climate science, we're going to talk in this session about sort of climate policy. And the idea behind this is I will give a brief sort of overview of how we can view climate change as well as other environmental issues through the lens of economics. So just a forewarning, there'll be a lot of demand and supply graphs. I can only apologise for that. And then after that, and I'll give you sort of an overview of things like the tragedy of the commons, and I'll pass over to Lucas, who'll give more of an overview of what the specific kind of things we can do to try and address climate change through policy. So first of all, my name's Dominic White. I'm a postdoctoral associate here at the Centre for Sustainability, Science and Strategy. Currently, I'm focusing on the impact of drought in the Mississippi River Basin, so I use an economy-wide model to try and explore the impacts of that drought on production in things like irrigated and rain-fed crops. And my background is in economics. Okay, so very quickly, just some ground rules. I realise in economics, as in many topics, but maybe economics is kind of the worst for it, we use a lot of jargon. So if there's a word that I use at some point or some acronym that I use without adequately explaining it, please raise your hand and I'll give you a proper description of it. Of course, questions are welcome as before, but please keep your deeper discussions for the end of our talks. But again, any small clarifying questions, just ask on the fly, that's fine. We are of course not spokespeople for the Centre for Sustainability, Science and Strategy, MIT or any other sponsors. These are all opinions of ourselves. We put these slides together. And I'd like to thank previous contributors to this course which helped sort of construct the slide deck. Okay. There we go. So first of all, I'm just going to give a brief description of environmental policy and sort of why we need it, and then I'll dive into sort of very briefly what economics is and then how we can integrate environmental policy within economics. So first of all, from a sort of economic standpoint, policies are required when a group of people cannot find the optimal solution by themselves without any rules, and usually occurs when there are lots of people without any rules. Okay, now there's a lot of discussion about what an optimal solution is, and I'll hopefully sort of get a bit closer to that when we're looking at what externalities are and things like that. But it's particularly important to realise that policies are very important in the environmental domain. Now, why is that? It's because people value the natural environment differently. So if we're doing something that impacts the natural environment and everyone's valuing that environment differently, how do we find a common solution? How do we find an optimal solution? And quite often this is why you need an environmental policy that sort of cuts through that without individuals trying to make their own minds up. And what do I mean by people valuing the environment differently? It could be something like you prefer being out in nature and going for a walk on your weekend compared to someone who stays at home and games or watches TV, for example. So immediately you have a different value and you have a different interaction with the environment with each individual. So those individuals can't find an optimal solution because they're coming from different sort of perspectives there. And it's also important to note that people's perception of a good or healthy environment are different. Okay, so you might have an expert in botany or biology who can look at a degraded forest and say, oh, that's not a healthy environment. And you can have someone else who's quite happy to look at sort of just a basic field of grass and say, great, that's a healthy environment. Okay, so you've got to sort of try and cut through that again with some sort of environmental policy because all of these people are coming from different perspectives. It's also important to note, and this is a problem in any economic issue, natural or environmental resources are limited. Okay? And so when you have limited resources, we as individuals all have unlimited wants and these wants and needs are changing all the time. So how do we best preserve or use these natural or environmental resources? And the best way to do it is have a policy in place that tries to actively sort of represent society and finds this optimal solution. Okay, so I've thrown a lot of terms at you there. And I think before we get into sort of what potential policies are and how we can sort of approach this climate change problem or other environmental issues, it's important to understand what economics actually is, and also how we view environmental problems from an economic perspective. So first of all, economics is the study of how people make choices when faced with opportunity costs and constraints. So first of all, what is an opportunity cost? That is the potential thing you could have done with your money rather than the alternative that you made. Okay, so for example, if I was going to a store and I was buying a chocolate bar, I could have spent that money on something else. Okay, so the opportunity cost of me purchasing a chocolate bar is the next best alternative that I could have paid for. I don't know, it could have been a lollipop, for example. So you've got to incorporate that when you're thinking about economic decisions. Another definition of economics which is commonly used is we are in a world of unlimited needs and wants with limited resources, and how do we distribute those resources? And that is essentially what economics is trying to get to the bottom of. And it's important to note it involves the description and analysis of the production, distribution and consumption of goods and services. So I'm sure many of you have heard of the concepts of goods and services before, but just to give you a quick refresher, a good is a tangible product that you can buy, so a chocolate bar is a great example. A service is intangible, but it's still something you pay for, so for example a haircut or consulting services, for example. Now, within economics, there are two broad categories. The first is microeconomics, and that is individuals making individual decisions. And that can be individuals as in consumers, or it can be individuals as in individual firms making production decisions. So it sort of looks at the very small scale decision making, individual markets, that kind of thing. The second is macroeconomics, so that's the economy as a whole. So when you hear about things like interest rates and you have a recession, or we have changes in the overall labour force, that kind of thing, that is a macroeconomics perspective. Okay, so you have microeconomic decisions that can affect the macroeconomy. Okay, and it's important to note when you're designing climate change policy, you need to consider both microeconomics, so individual decision makings, as well as macroeconomics, so the impact on the overall economy. Okay, so again, I said there'd be a few sort of curves, and I again apologise for that, but here we have an individual market. Okay, and so in neoclassical economics, we have this idea of demand and supply. So when we're looking at this market, I'll use chocolate bars again. On the y-axis, we have price, and on the x-axis, we have quantity. Okay, and when we're looking at the demand curve, you can see it slopes downward with price. So the only way you're going to consume more is if the price goes down. Now, the best way of thinking about this, when we look at chocolate bars, the first chocolate bar that you consume, you value quite highly, right? And once you've consumed that initial chocolate bar, the second one, you might be a little bit full. So you don't value it quite as much as the first chocolate bar, okay? So to purchase 2 chocolate bars, you need the price to be a bit lower. And then the third one, you're even more full, so you need the price to be lower, and that is why we have this downward sloping demand curve. So another way of thinking of the demand curve is the marginal benefit, so the additional benefit you get from consuming 1 extra unit of this good or service. And it's also worth considering that the demand represents the willingness to pay of consumers. And so when you can look at an individual market or a group of markets, and you have a downward sloping demand curve or marginal benefit. Okay, and then you also have the supply curve. So what does that represent? That's the production of this good or service, the production of chocolate bars, okay? And so typically the supply of goods or services is dependent on price. And so it doesn't cost too much to produce the first chocolate bar, okay? So they're willing to produce the first chocolate bar for a low price. But as you produce more, it costs more to produce, so you need the price to go up, okay? And so we have here a market where you have a supply curve going upwards because they need the price to go up to produce more, or it represents the marginal cost of producing an additional unit of the good or service. And you have a demand curve sloping downwards. And when you put those together, we end up with a point in the middle where these two cross, And that's called a market equilibrium, where you have an equilibrium price and an equilibrium quantity. If we have nothing going on, we say that that point in equilibrium is the efficient point or the optimal solution for that market. Okay, so you have that initial market where you have an equilibrium, there's nothing else going on, you're consuming chocolate bars, everyone's happy, okay? You're sitting at an equilibrium. Now I'm going to introduce the concept of an externality. So an externality is an indirect effect from the consumption or production of goods or services, okay? So from eating that chocolate bar, you could have either a net positive or a net negative effect that is not being represented in the market. It's not being priced in, okay? So they are measured by economists as social costs or social benefits, okay? So externalities can be positive. If we think about something like education or research and development, when you have a consumption of education, when society as a whole becomes more educated, there is additional benefits outside the market that we don't see when making that initial transaction, okay? There's usually a reduction in crime, there's usually an increase in the amount of healthcare provided, there's an improvement in the level of democracy, for example. When you have research and development, you're producing things that are improving society overall, typically. But externalities can also be negative, okay? So whenever you have pollution from production, which causes things like climate change, as soon as you are producing something that has pollution involved, that is usually not priced into that initial transaction. What is priced in is the usual sort of production costs that you have. So it might be labour, it might be your capital costs, it might be other intermediate inputs that you put in. So you use goods to produce goods, for example. But on top of that, you have pollution that is produced. Okay? And that pollution is a negative externality. It's having an impact on society that's outside of the market, and it's not being included within that demand and supply curve. Okay? You can also have something like smoking, and it's not so much the production of cigarettes, it's more people smoking themselves. You then have secondhand smoke, you then have a negative impact on the healthcare system, etc., etc. That is not included within that initial transaction and within that initial price. So an externality is something that's happening outside of those initial production costs and costs to society. So how does this look when we include it within that sort of demand and supply curve that I was talking about before? So first I'll look at an example of a positive externality. So as I said before, education is a positive externality. If we were working within just the normal demand and supply curve, we would have a equilibrium price at P star and an equilibrium quantity at Q star. Okay? But you can see we have the normal demand curve, which is a marginal private benefit. So that's the benefit to the individual purchasing this education. And then we have an additional curve that sits above that, and that's the marginal social benefit. So that's for every quantity of, every amount of tertiary education that's consumed, you have this additional benefit to society, which again is in the form of a reduction in crime, a better healthcare for individuals. Okay? And so in economics, when you have a positive externality, this P star and Q star is no longer an optimal or efficient solution, okay? Because you're missing this marginal social benefit, okay? So to have an optimal solution, you need to include that social benefit within your decision making, and you need to shift from P star to P double star, okay? So you have a higher quantity of tertiary education being consumed than you would in a private case, okay? So that is how a positive externality works, and you want, within economics, and the reason why you need a policy involved is to push from P star to P double star and get to that efficient equilibrium. Okay, so thinking about the same concept in a negative externality, and this is from the production side. So you can have externalities from both production and consumption. It's important to note that. Okay, again, we have coal electricity production, and you have demand for that and you have supply for it. We have an initial equilibrium at P star and Q star, but every time you consume coal electricity, you have carbon dioxide entering the atmosphere. Now, the cost of that carbon dioxide in terms of health effects and climate change and all the additional impacts that come from that are not included in that initial transaction. Okay? So you have a marginal social cost which is higher than the marginal private cost. Okay? So you have this indirect impact that is not being contained within the market. Right? So we're not at an optimal point, or we're not at an efficient point when we're sitting at that initial equilibrium of P star and Q star. And so what we need in this situation is to have some sort of policy in place that pushes society to P star star and Q star star, which is a lower level of consumption or a lower market equilibrium than we would have had before. You see that quantity is moving to the left there. And as I said before, you can have externalities on both the supply side and on the demand side, and in some cases you have it happening at the same time. Okay, but I've split it up just for sort of more of a simplistic overview of what we're dealing with. So if we look at a negative externality from the consumer side or from the demand side, we can think of the idea of using diesel cars. Okay, so we know that diesel cars have quite a lot of emissions that come out of their tailpipe, but when you purchase that diesel car and then use it on the road, that is not represented in that initial transaction. Okay, so you're operating at P star and Q star, but the actual marginal social benefit is lower than the marginal private benefit when you're purchasing that car, because you're emitting emissions. Those emissions affect other people, but that impact or that cost on society is not being included within that initial transaction. So we're not at an efficient point at P star and Q star. We need to shift to P star star and Q star star. Okay, so that's the basic concept of what we're dealing with when we're thinking about sort of climate change and environmental issues within economics. Now, a problem that we have is, you know, what is the difference between the marginal private benefit and the marginal social benefit? You know, there's a lot of science that sits behind that, but it's really hard to measure what the actual impact of climate change is on society, and then trying to figure out what the actual price should be. Okay, so there's a couple of ways you can do it. You can try and focus on quantity, or you can try and focus on price, or you can try and do both. You can implement regulations that try and get people to shift away from a technology altogether, all of which Lucas will go into a bit more detail, and we'll give some real-world examples tomorrow as well. Okay, now to give you an introduction to another topic within economics is the tragedy of the commons. Okay, so you probably would have heard of this at some point. The idea comes from common land within England, and essentially you have a shared resource. So in the case of this picture, the shared resource is that plot of land. Okay, no one owns that plot of land, it is shared by society. Within this theory, you have individuals that don't communicate with each other, but they all have interests to make money, okay, as we all do in society. Now, this plot of land has a carrying capacity. So if it's being used for sheep, in this case you have 9 sheep, and then if you include any more sheep above that, then the land starts to degrade, okay? Because you've got too many sheep grazing on this land, it can't grow back, the nutrients in the soil get degraded, etc., etc. If you have an individual who owns this plot of land, they will know this carrying capacity and they won't go over it, because it will affect their profits when they go over that carrying capacity, and they'll say, no, okay, I'll keep it to 9 sheep and I'll keep maintaining this land into the future. When you have this shared resource and you have a bunch of individuals using the same resource, they're all acting within their own interests, and as soon as it goes above the carrying capacity, the impact on profits is shared between the farmers. Okay, so they're all acting individually. There is now a shared impact, so it's spread between multiple people rather than just being on one person. They will continue to produce, or they'll continue to put sheep on that land as long as they make money from it. And the key thing is they're not communicating with each other. And eventually you get to a point where you have a degradation in that shared resource, so this common will no longer be able to be used by individuals. That is the basic concept between tragedy of the commons. Now, in reality, you know, the idea of having people not communicating with each other and knowing what the optimal sort of carrying capacity of the land is kind of unrealistic. You do have situations where people don't want to talk to each other because they have their own private interests, but generally they do know what the carrying capacity is. A really good example is fisheries with this. If you think about the ocean, you know, you've got a big stock of fish. Individuals will act in a way where they will degrade that resource until it's completely depleted, and that's why we have things like fishing quotas. Okay, so related to this concept, we have this idea of public goods. So public goods are goods which individuals cannot be excluded from using. So if you think about that land, anyone can put their sheep on that land. And use by one individual does not reduce the availability to others. Okay? And so really key examples include things like environmental protection. If you protect the environment for one person, you're protecting it for everyone, right? National security. If you're in a country and there's some sort of national security, you having that national security doesn't prevent someone else from having it. And if someone else comes into the country, again, they're also protected by it. It doesn't change how much you're protected by national security. And also street lighting. Okay, so everyone benefits from street lighting. And that's a difference between public goods and private goods, is that private goods, you can exclude people from them. Okay, so the natural environment and its related benefits are public goods. Okay, so we all benefit from the natural environment. Me having some benefits from the natural environment doesn't stop someone else having benefits from the natural environment. And like the tragedy of the commons, it lies open to exploitation and it lies open to that resource being degraded. Okay, and so it's important to note very similarly that the climate change is a tragedy of the commons problem. So greenhouse gas emitting activities give immediate tangible benefits. So all of these individuals are making as much profit as possible. They're acting as individuals. And they have this externality of greenhouse gas emissions. But the negative impacts from that, so in the form of pollution, are distributed over time and over populations. So if you think back to that very simple tragedy of the commons example, the reason why these individuals over-farm this land is because the impacts are spread between a bunch of individuals. It's not just one person acting on their own. When you have a bunch of people polluting, it all goes into the atmosphere and those effects are felt by everyone. It's not just one individual. Okay, so it's a very clear sort of tragedy of the commons example. And it should be noted that the removal of CO2 emissions, which typically is through planting trees, are public goods. And you can't exclude any country from sharing the atmosphere. So if one country decides to plant a load of trees, you're not excluding anyone else from getting the benefits from less CO2 in the atmosphere, and there sits something called a free rider problem. So people will sit on the back of policies of other countries and think, well, I don't need to do anything because they're planting lots of trees over there. Okay, so hopefully that gives you sort of a bit of an overview of how we view environmental issues from an economic perspective. Okay, and obviously there's lots of other things that sit behind that, but it's the idea of, you know, you have these indirect effects that are not being captured in the market, and the best way to do that is by introducing some sort of policy. So I'll hand over to Lucas now, who will talk about some of the policies that we can introduce to try and tackle this problem.
Thank you. Well, actually, I'll do that tomorrow, I think. Good evening, everyone. So yeah, I'm going to talk about how to fight climate change and how do we protect this public good that environment is. So my name is Lucas, and I'm a postdoc associate working on different rebating schemes when it comes to taxing heavy industries and trade-exposed industries. So I'm going to give you an overview of how technically we can do to fight this the problem of climate change. So I think quite a bit of answers have been given before, but we will go a little bit more into details, and tomorrow we'll take a look at how we can control or steer the deployment of different technical strategies. So to combat climate change, we need to think about it as a system where we have the human society, us having needs and wants, and to satisfy these needs and wants, we need energy, land, and materials, among others. And it happens that processing energy, managing land, extracting materials emits CO2 and other greenhouse gases, which in turn affect climate change. So one way to categorize different strategies to combat climate change is first have an impact on the demand. Mitigation. So mitigation, I'm going to go after, is to avoid CO2 emissions. A third option is to suck the CO2 out of the atmosphere using carbon dioxide removal. Geoengineering, which has been mentioned before, but we'll take a closer look at it, and adaptation. So one way also to put in this problem into an equation is the chaotic decomposition, which says that what we emit is equal to our activity multiplied by the amount of energy per activity we need to bring, and the emissions associated to this energy. But again, this is a very simplified way to decompose emissions here. We could also like include population, GDP, not only energy but land, materials, etc. But this is some way to describe the emissions problem. Okay, so I'll go to that after. So I'll go first with adaptation. So adaptation is adjusting our societies, ecosystems, and economies to reduce harm from climate impacts that are already happening around the world. So this figure here is just to show that there are different stakes around the globe, and as a continent, you have different threats, but also at the local level. And some of these climate change impacts are already unavoidable and already happened. So we just mentioned before that there were fires, pretty harmful fires in Canada last year. We already experienced massive floods in the US and elsewhere, heat waves, especially in the northern hemisphere. So these impacts of climate change, human-induced impact of climate change, are already happening, and we want to protect ourselves, even though we cannot do anything now to avoid them. We want to avoid them, of course, because it's harmful for our health, for our infrastructures, our buildings. And there are also impact on foods, on agriculture and stuff. So one way to adapt, well, adaptation is many things. This is a summary of on top the threats, and in the picture different strategies to tackle the threats. So for example, for flooding, you might want to build a levee to like keep the rain apart of the buildings. In terms of heat wave, shade trees can be planted in the cities, or we can also like do cool roof by painting the roofs in white. And for agriculture, to avoid drought, you might want to implement some stream irrigation systems to like really control the water that is needed for agriculture. We can also develop drought-resistant crops, so more like GMO research. Yeah, so this is just to give you an overview of what can be done. And we can also have an impact on the demand. So there's two ways to have an impact on the demand. Demand reduction involves reducing the need of primary materials, fuels, land, and energy, and their associated greenhouse gas emissions. So we can do it either by efficiency or sufficiency. So efficiency is really like we do the same, but we want to use less materials, energy, and land to satisfy this need. So we don't want to sacrifice our needs and wants. While sufficiency says, okay, maybe we can act on energy, material, and land in the first place just by reducing our needs and wants. And of course, these can be combined. Um, so the efficiency strategy is more an engineering strategy where you want to optimize the way you convert a certain amount of energy or land or material into some basic good. And sufficiency is more like a societal issue and stake that is politically and socially sensitive, because people don't necessarily want to reduce their consumption. So examples of that are, for example, in mobility, you might want to prefer to bike instead of taking your diesel car, or if you want to go with the efficiency measure, you might want to invest in an electric car. In buildings, one strategy is to reduce the area per people inside the building. So basically, we could put a lot more people here to satisfy the basic good of giving this presentation to you. But we can also act on the heating and the cooling of this building, like providing more efficient machines to heat and cool this building. In terms of lighting, we can, for a sufficiency side, use more natural lights, and or on the efficiency side, invest in LED bulbs. Well, a different bunch of different examples to show the difference between efficiency and sufficiency, but basically efficiency is do the same with less, and sufficiency is do less or do it differently. So this was for the demand reduction part, but we can also directly act on our emissions by avoiding the emissions. So reducing GHG emissions by changing the supply of primary energy and materials, or innovation in low carbon processes. So very famous ones are, of course, wind and solar, and renewables in general. This graph that I show here, that is very small, I'm sorry for that, represents a diagram that was shown in the last IPCC 6 assessment report that is summarizing for different sectors the main mitigation strategy we can do now or in the future. And on the x-axis, you have the potential contribution of the listed strategies, and they are colored with their cost. So when it's blue, it's a lower cost, and the redder it gets, the higher, the more expensive it gets. So this is very important to know, because we don't want, well, if we have to invest into something, we want to do it first with what is the less expensive and where it is the more efficient in terms of potential, how much CO2 we can avoid for the lowest price. So costs and potentials are crucial into our are crucial to our mitigation strategy. They are also very sensitive to investments. If you have to invest a lot of capital in some strategy, is different from like just having a less intensive capital machine, for example. It's relative also to maturity, because a lot of these listed options here are not completely mature. So we can actually measure that, and there's an index to measure like how ready the technology is to be invested in and deployed massively. There's also the issue of acceptability by us, by the people, and environmental externalities that Tom just explained. So for example, here, if I want to invest in solar or in, let's say, wind, we have to take into consideration that it's not just about costs and potentials, but also that we want to extract a significant amount of materials that it's going to maybe potentially impact the environment, like in terms of water or in terms of pollution of lands. The other way to think about how to combat climate change is to not avoid the CO2 to penetrate the atmosphere, but to suck it out of the atmosphere, to store it permanently, either in the geosphere or the biosphere, or even also in the ocean now. So this strategy encompasses a lot of different technologies that are represented here in squares. So I'm not going to go through all of them, but give some examples. So the greenish, bluish 4 squares are related to enhanced ecosystem management. So basically, we want to enhance what nature already does. So, for example, the ocean already absorbs CO2, but we might want to optimize his role in doing that. And we can do it the same with afforestation and reforestation, for example. So afforestation is planting trees where there wasn't before, but reforestation is just replanting the trees we have cut off. These 2 examples I just gave are, as you can see with the storage duration axis here, are short-term carbon dioxide removal techniques. They only keep the CO2 out of the atmosphere for some decades. And if we want to have an impactful carbon dioxide removal strategy, we want to consider also like long-term removal strategies that I'm going to go through after that. Another way to, another technique to remove CO2 from the atmosphere is to go with biomass conversion. So for example, there's a, something that maybe is not well known is the terrestrial biomass burial. So the idea here is just to grow trees. And while they grow, they absorb CO2. And once they are done absorbing CO2, they have done their job, they did their job, we cut them off and we bury them underground into like sealed boxes that don't interact with the geosphere and essentially the soil, and keep the CO2 the trees have been capturing below the ground. This is also very controversial. Well, overall, carbon dioxide removal is very controversial, but this one is particularly because it's considered by some people as a waste of a time to have grown trees, but you don't really use it in the end, because you could have used it to like be transformed into some fuels or for like liquids for our tanks or to heat our homes. Another way is geochemical carbon removal, so the red squares, which is here about enhancing, for example, the natural reaction that occurs when the rocks react with CO2 naturally, and so we can spread some chemicals on them to enhance this reaction. And maybe the most known of these techniques are engineered ones, so either direct air capture and storage, or here it's just a machine that pumps the CO2 out of the atmosphere and store it underground by into like carbon reservoirs that are maintained usually by oil and gas companies, because they have the skills, geoengineering skills to do that. So yeah, this is an overview of CDR then, and we've already talked about it before, but this is a picture to represent geoengineering, which is about combating not the emissions, but the greenhouse effect by itself. So limiting the amount of solar rays that penetrates the Earth's atmosphere. So basically, the idea is to prevent a small fraction of the sun, of the solar radiations to penetrate the atmosphere. There are 3 or 4 main techniques to do that. One below is like to go on a boat and spread some sea salts directly in the trees. This will have the effect to the trees will reflect more solar radiation out of our atmosphere. The other one, which is not a, here you don't take a boat, but you take a plane and you spread more elaborate chemicals or aerosols in the stratosphere, so in higher layer of the atmosphere, and it will also have the effect to reflect more solar radiations out of the atmosphere. And the other one is to actually tackle the issue before the solar radiation entered the atmosphere by setting some mirrors, like for example through satellites, or to put in orbit mirrors that will reflect the solar radiation, and this way solar radiation don't even penetrate the atmosphere. So of course it comes with a lot of questions behind that, because whatever chemicals or aerosols you spread out in the atmosphere may have impact on our food, because it can just come down to the soil, and also on our health and everything. And the other main issue behind that is like the governance. How do you manage the strategy, and how you coordinate with other countries and other parties to do that? Because if you do that in your country or in your territorial sea, it might have other impacts on the neighbor. So this is very tricky, and this is very controversial also for that. I know Bill Gates invests a lot in this kind of strategy. And then, okay, so this is my mistake here. So having given you an overview of what we can do, well, the question is, how do we implement that in real life? And one option is actually we can do nothing, and we will have the disastrous impact that were already discussed and showed before. So in economics, when we want to assess the deployment of a technology, we usually compare it to what we call the business as usual, or BAU, which is a scenario likely to be a mix of adaptation and suffering. So basically, we don't want to do nothing about our emissions, but we want to still prevent from the harmful effects of climate change to happen. This business as usual has become less popular in recent research, because now with the Paris Agreement, there are policies that have been implemented, and so assuming that we won't do anything about climate change is now wrong, but it can still be used as a bottom line for policy evaluation. And we'll talk about this tomorrow. And so now we more refer to current trends. So what is called current trends can be referred to as what we call nationally determined contributions, or NDC. So an NDC is a country's climate action plan under the Paris Agreement, outlining its goals to reduce emissions and adapt. So it both mixes adaptation, demand reduction measures, if any, mitigation, carbon dioxide removal, if any, and geoengineering. So each country, each party that have signed the Paris Agreement has to first design a plan, implement it, and report it to other countries, so the other countries can actually see what is being done and if it's effective. So this has been set up and imagined to kind of have a review process and build trust among parties to like keep doing things. And so this bottom line is important to have in mind, again, because if we want to go further, we invest more in the technologies I've just presented. We want to know compared to what, and this is the bottom line. And currently, the current trends or the nationally determined contributions have been assessed not to be enough to tackle climate change effectively, and will lead us to a world like above 2 degrees Celsius temperature elevation. I think that's it. Yeah. Do we still have some time, or should we? Yeah, that's it. All right. Thank you.
Yeah. So if anyone's got any questions, we'll come around with microphones, and I do realise it's 5 o'clock already, but we'll happily answer questions.
What do we have any kind of more precise evaluation of the effect of the do nothing? We're talking about sufferings and things that can we put some numbers in there, because there were a lot of science talking about numbers. Can we talk about in terms of, I don't know, monetary, financials, or deaths, or disease, or whatever, or do we have anything? Because we keep on talking about, yeah, it would be bad.
Yeah, of course.
I have to jokingly say, I don't think most of the billionaires will survive, so they are not to be suffered too much.
So we can measure whatever scenario we want to look at in terms of GDP, of course, and so GDP, population also, death, emissions in general, pollution in general. So not CO2 emission, CO2 pollution, but other harmful chemicals. We can measure that and compare it into our scenarios. I don't have real numbers to give you unless the temperature change that is anticipated. If we do nothing, we will go over 3 degrees or 4 degrees Celsius compared to pre-industrial levels. And consequently more extreme events. But in terms of death, so, well, for example, death is a very tricky parameter or variable to assess. If we do nothing, it's a very difficult variable to get a sense of what it could be if we do nothing or if we do something. But there are estimations out there. I don't have any numbers here, but
I will note.
Yeah.
Michael. Yeah, so I will note in our Climate Science 102 discussion tomorrow, we will talk about like changes that we'll see in like extreme tropical storms or flooding or droughts. Like we will put numbers under different scenarios. So we will touch upon like the actual concrete numbers of climate impacts tomorrow.
I will also add that thinking about the do nothing scenario and trying to attribute the value of impacts, whether that be on mortality or even on GDP, compared to a situation where there's no climate change, it's a very difficult thing to do. So there is some research looking at that, but there's so many different parameters that go into it. It does get quite complicated to, if we have a do nothing scenario, what are we comparing that to? A scenario where there's no climate change at all? What does that world look like? You know, we wouldn't have had certain breakthroughs in technology if we didn't have climate change. So it is quite a difficult thing to examine.
Thank you so much for how you have explained all of this, from the economics to how we can mitigate climate change. So I have a question, and it's about one of the ways that we can mitigate. You talked about carbon capture, carbon dioxide removal, and I'm curious. I know that carbon dioxide is one of the gases we need in the atmosphere. So with these technologies that are out for carbon dioxide removal, is there a threshold above which, it maintains some of those that we need for, living on the earth? I'm just curious about how it will all work together.
So are you worried that we would remove
Yes,
more
I'm
CO2 than needed to live?
yes, I'm curious
That-
about
that
what
won't
is the
happen.
measure
No.
of, yeah.
So what we want to do is to stabilize the emissions. So we have zero emissions, and so, net emissions. So that what we emit is compensated by what we remove. This is a very optimistic scenario where it happens actually globally, not only like on your side, on our country side, but and if you do that, temperatures are going to decline quite or stabilize, but the concentration of CO2, that's what you mean, right?
Yes.
Is gonna remain stable for a while and then decrease, right? So I don't think there's a secure level of concentration of CO2 emissions so we can leave. Maybe the scientists know more about that, but yeah, Eric?
I just want to note there was an extra slide I almost included in the first section where I could sort of compare how much CO2 is actually going into the atmosphere every year and how much is being removed by CDR. And currently, we are emitting about 1 million times more CO2 per year than we are taking in by CDR. So CDR is not yet a silver bullet in this sense, and we're not really anywhere close to removing more CO2 than we had in pre-industrial levels. But if we were more efficient, that would be a consideration worth noting. But anyways, thanks.
Okay, if there's not any more questions, we'll let you go for today and see you all tomorrow. Thank you very much for coming and participating.
Thank you.